and thank you all for your staying power to stay to the end of the session of this second day. I'm sure you're all dying to go home and get changed and put your ball shoes on for the gala dinner, but please bear with me for another 15 minutes. I am presenting the outcomes of a study we did last year about spatial data supply chains in Australia and New Zealand. And we're talking about spatial data supply chains here in a slightly different scope and concept as to what Ezra was talking about earlier as SDI chains. This is really about the process of gathering information, data collection, standardizing that, maintaining that in a consistent way, and then feeding that into an SDI. So we're talking really about the fundamental data sets, the supply chain of the fundamental data sets that form the pillars of SDIs. So talk to you a little bit about why we did this project in the first place. Did we just do it because we had fun, or was there a more pressing reason behind it? And then talk about those spatial data supply chains and why you should really care about them. And then, of course, what did we find? What are some of the conclusions we can draw, and where to from here? So we all know, SDIs are about delivering fundamental spatial data. If you don't know that, you probably should be in the conference next door. So it's about providing that common reference framework of reliable, consistent, and authoritative data that provides like a canvas to work upon and value add and share your data, your environmental data, etc. And it's really important that that is a reliable, consistent data set of a known quality. And that makes it a critical enabler for SDIs. And quite often we see that this data is collected from multiple sources, so it needs to be collated and then consistently and reliably integrated, standardized in an automated and distributed way. And in Australia we have, for instance, an address database, a national address database. It's called GNAF, that is compiled from multiple sources. GeoFabric is the hydrographic data set, so the national connected data set of streams, groundwater, boreholes, lakes, etc. And these are all data sets that are continuously updated, but form also that fundamental framework and canvas upon which to build applications. And a couple of years ago, I was sitting down with a number of gentlemen from 3 organizations. One was working really hard and spending a lot of money for creating such a supply chain for address data. Another one was doing the same thing for hydrographic data sets. And the third gentleman was doing exactly that for topographic data sets. And we're having a conversation about the challenges and the technologies that were being used and the kind of algorithms and tools, and came to the conclusion that each one of these people, and they were actually living and working in the same city in Australia, each one of these people was reinventing that wheel. They were all trying to solve the same problems, or what looked like the same problems. And sort of you could see the light bulb go on and say, why are we doing this? Because it's very expensive, it's taking us years and years and years and years. Is there any way we can share our experiences and look at the alignment between those spatial data supply chains? And that's really what led to our project. So we started this project, and the first thing that we did is try and analyze what we actually understand when we talk about such a supply chain. And it turned out that even though different people in literature and in the practice sort of have different names for the different steps and they're slightly different, there's actually quite a consistent pattern. And it goes from obviously data is collected, and then somehow published to the organization that is responsible for the collation and maintenance of that supply chain. Subsequently, that data needs to be standardized in the right format, the right data models, and then integrated. So there needs to be edge matching happening, and making sure that it all fits together. And then there is a maintenance, so that this comes in continuously. There's updates, there's version management, and then eventually, for it to be used, obviously it needs to be extracted out of your central database, which can be a physically central database, data warehouse, but can of course be a virtual environment, and then delivered to your end users. So that's sort of that chain of tasks, that workflow of publish, standardize, integrate, maintain, extract, deliver, sort of the common conceptual model. And then we said, well, okay, well, let's have another look at best practices and what makes actually for a good and efficient spatial data supply chain. Well, it has to be, of course, have that principle of a single point of truth. You can't have multiple versions sitting around. And it needs to be able to be continuously upgradable. You can't sort of shut down your system next time an update or an update from one of your suppliers comes in. And that process needs to be continuous and well managed. At the same time, you can have your data centrally in a generic form, but then you have to generate supply views. So what do I mean by supply views? Well, you can have a national road database, for example, but the way you present that to your map makers who will use it for cartographic purposes, or for people for navigation purposes, or for engineering purposes will be completely different. The first one will have it in nice colors for cartographic purposes. The second one for navigation is really only interested in some of the road attributes, distances, and the connectivity, sort of topological network connectivity. Whereas if you are using it for engineering construction purposes, you really want to know not the line, but the polygon, the width, and whether there are pavements on the sides, etc., and the materials underneath. And so that's basically what we mean with different supply views. Then, of course, you have to have version management, because if someone comes and wants to project some data 3 years old onto your fundamental data, you need to be able to deliver that 3-year-old data set. And last but not least, and this brings us back to the currency, quality, and reliability, you need to be managing that process as automated as possible. That gives you consistency, it gives you also affordability, and it gives you that reliability. So once you start looking at these things, you can start maybe realizing what a daunting and expensive process that is, especially if multiple organizations are doing that, trying to set that up. So why is that not happening? Well, that's one of the key things we wanted to look at, but we did realize and we did observe that there was quite a range of initiatives that were trying to solve these problems in relative isolation. We thought when we started we had 3, maybe 4 organizations, but then we started throwing the net out a bit more wider in Australia and New Zealand, and we found actually over 40 that were doing that, some of which we included. And they were all working on the same problem, it seemed, reinventing their own wheels and duplicating efforts. So the real purpose of this study was to identify, what work was being duplicated, and can some of that be exchanged, shared, can some collaborative investments being made to solve the same problems for gaps. And that's what we're doing, that's what we did, identifying those reusable components and identifying joint investment opportunities. Okay, so we defined a 3-stage process, and what I'm presenting here is the outcomes of stage 1, which is the quick scan of the relevant initiatives, where we looked at initiatives in Australia and New Zealand, created an analysis framework, and identify strategic partners and opportunities and the key projects that we would further then look into in more detail in stage 2, which is planned for later this year, and then finally see if we can demonstrate some of those outcomes. So we approached 37 projects in Australia and New Zealand with workshops and surveys. We got 32 responses, which is a very high response rate. But the initial findings were already quite telling. There were largely, almost without exclusion, government organizations doing this, very few private sector. And only 7 out of those 32 actually automated that whole supply chain, which is actually a validation of, you know, what one of our premises is. Like, the need to automate is clear, but most of them don't. So there's a lot of manual processes, and it means cost, it means errors, and it means you know, delay. 50%, half of them were in pre-production stages. They were also still developing the process, so there's a lot of room for there. And only 6 have a full long-term sustainable governance framework in place. That means they had actually thought about and implemented what after we built this thing. After we built this thing, how do we maintain the relationship with our providers? How do we maintain our systems? What do we do if something goes down? How do we deal with that? How do we maintain a certain quality level for our customers? So lots to do. One of the questions we asked is, why are you doing this? Why are you setting up this spatial data supply chain? In other words, what is your business driver? So of the 32 projects, these are the responses we got. So anyone find something funny about this list? Look at that one. Improve value and service to stakeholders. Only 3, 10%, 9% responded that. They actually had their end users of the data in mind. The rest of them was, well, we need to maintain data because that's what we're doing anyway. Or there's some kind of statutory obligation. So it's very inward-looking sort of business drivers. Draw your own conclusions. The audience, and we asked them, so okay, who do you do this for? Who do you deliver your data for? Again, the vast majority, government agencies. So just what we see is a lot of government agencies creating data for other government agencies, public organizations, scientific community, significant part, and only at the very last, the general public, which actually makes sense. You know, we're infrastructure development, which is, you know, actually more meant for value adders to work with. And then we looked at sort of those best practice elements, providing a single point of truth, continuous updates, do you have supply views, etc., versioning, automatic updates, and do you use any mandated standards? And the blue bars are the number of people who have, a number of projects and supply chains that have that, and as you go further down, that goes down as well. So, you know, single point of truth, continuous updates, that's something that is very well established. Supply views, yes, and then, but once you start talking about what's really fundamental stuff, like managing your versions, that's only like 17%, so 70%, so a significant part of them don't even manage their versioning. So lots of room for improvement. How mature is your systems? This is the, you know, have you got a good, is it a production system with a governance framework in place? And see, only about half really of these systems are in production. The other half are still being developed. So I guess we are in time to potentially look at synergies between them and improve them. So then we decided, okay, well, if we now had to define sort of best of breed projects that we could actually have a closer look at and see if they can exchange and reuse some of their components, we said, okay, well, let's look at the ones that have automated the publishing part of that supply chain, the maintenance and the extraction, and are in production. And that gave us a short list for phase 2, where we have a closer look under the hood, and we will identify those potential areas for collaboration, but need to look at it much more technical detail and see how much reusability is there actually between the different projects. And this probably doesn't mean much to you if you're not from that hemisphere, but these are the ones we've identified. So, in conclusion, if you look at the status of spatial data supply chains in Australia and New Zealand, you can pretty much say that at least half of them are still in their infancy. It's also very much a supply-driven approach. It's by government, for government, with very little understanding of who the end users are and what they were actually looking for. That's a very disturbing conclusion, I must say. And they get developed in isolation. We've identified significant capability gaps in the areas of automation, maturity, adoption of standards. And that means there's plenty of opportunity for collaboration. And you could argue that there are lots of emperors out there that may not be wearing all that many clothes. So, the next step, we need to integrate a few more areas for Queensland and New South Wales, which are 2 jurisdictions in Australia, into phase 1 analysis. And then from, in this case, it's already progressed to the second half of 2012, we go into the detailed analysis of those shortlisted projects, develop a reference architecture, so sort of a best practice conceptual architecture, and use that to define a research agenda and the scoping up a collaborative demonstration project. So hopefully in one of the next Inspire conferences I'll be able to tell you a little bit more on how that is developing. Thank you very much, and thank you for your attention.
Question? Yes. No, done.
And I have been dealing with the field of SDI and data production for more than a decade. And in all the presentations I understood there was a broader picture considered. And my experience is that most people dealing with spatial data do not keep the broader picture. And for me, there is a lack of something as architects or system planners or thinkers in the field. And I'm interested in your case and also in the other ones, how did you bring these people into the project and the activity you have done?
Okay, so if I understand your question correctly, is how do you get the real end users involved early in the project? Is that what you... Huh?
Into the coordination process, into the planning process, how do you bring those who are not only specialists, but those having a broader mind in the sense of thinking about the system, and are the people brought from the field of education in spatial data, or do you take into your teams system engineers from IT field or architects in the sense?
Okay. Speaking from our experience, that is definitely not happening sufficiently, and that's probably one of the reasons why we see some of the failings to date in these systems. The solution, and it's very easy to say that here, is to get them involved early, and that means from very, very early on the stage, even if you think you are building fundamental architecture and infrastructure, start thinking about use cases. What are your key use cases? Start designing for that, even though 2-3 years down the track they may completely change or additional use cases may evolve, but you need to have something that you're targeting and you're focusing on, and it helps you to develop something that will actually be useful to some people at least. But it's definitely not happening enough.
Franco.
Question. A comment on Inspire from your point of view.
We see Inspire as an inspiration. Guess what? and we are already in Australia using a lot of the vision as well as the actual technical artifacts that are being developed as part of the Inspire program. So we will adopt, and we are in the process of adopting the good things from Inspire, while maybe avoiding some of the lessons learned, and trying to do it at maybe a shorter time frame with a smaller cost base.
No more questions? Yes.
Do the users know what they need? Do the end users, have you checked out if they know what they need?
Well, that's always a tricky question. I think Steve Jobs said it's not up to our customers to let us know what they need. We will do that for them. But unless you are someone of that stature, that's a very dangerous position to take. The situation is, in the projects we looked at in this study, is very much that if the business driver is we are fulfilling a legislative requirement or continuing to doing what we've always been doing, there's not really a need to look at users. You can actually achieve success without doing that. Do the users know what they need? Some do, but it's also very important to realize that some of your users of spatial data you couldn't possibly predict. And a lot of the mashup contests that we see are being done in Australia, and I assume they're being done in Europe as well, very clearly demonstrate that once you put data out there and make it available, people come up with weird and wonderful ways to use it that you couldn't possibly have dreamt of before.
Okay, thanks a lot.
Thank you.